Hello everyone, I'm Rachit. I work for IBM India Software Labs, Bangalore. And this is my first time in Sydney, and it's a really very beautiful city. And actually, I have met a lot of people around here. People here are very friendly, and they are friendly to me, they are friendly to each other. But it's not exactly the same case for our cricket teams. So basically, I am part of the team where we are building a platform which is offering a lot of cloud services. And one of the services which we offer is Hadoop and Spark clusters. And this service is running on containers, and it's been in production from past 6 months. And I'm using Docker containers and related technology from past 3 years. And I have been following Docker for, let's say, over 3 years now. And I have seen Docker evolving from the years, and I still remember my first meetup, Docker meetup, where I presented a session on multi-host Docker networking using Open vSwitch and GRE tunnels. So it was like basically I have to set up a bunch of scripts to get this running, but now it's fairly easy. We can do it in a single line like Docker create network. So here I am today to share the experience of running this service. So this is the more talk from the user experience of the containers, and hopefully you will have something to learn from here. So before we begin, let's put ourselves in the shoes of my customers, who are the data scientists, and what they are looking for. They want to do some analytical jobs. They want to do social media analytics, they want to do text analytics, and they want to run some R scripts or submit the Spark jobs to the cluster. So basically what they are looking for Hadoop clusters or Spark clusters on demand, and those clusters should come up very quickly, and they don't want to spend their time and energy in setting up those clusters or configuring those clusters. So they are just looking for those clusters. And let's say they have those clusters and they don't want to manage them also. They don't want to take the pain of like upgrading the OS versions, applying the patches on the operating systems. They don't want to take the pain of changing the version of Spark runtimes. They don't want to take the pain of or scaling up and down their clusters depending upon their workloads. So what it boils down to is they are looking for multi-node Hadoop clusters which should come up very quickly, and they want to do add and remove node operations. They want elasticity in their clusters. They want their clusters to be economical. It should not be that they have one big cluster which is always running and they are paying it even if they are not using it. And they want their clusters to become in a repeatable fashion. It should be the case that whenever they request a cluster, it should come up like 99% of chances. They don't have to retry again and again and again. And even if we have to like patch a cluster for some vulnerabilities, there should be minimal disruption when we are doing that activity. So, and they are also looking for something called as service composition. So in their clusters, they don't need all the Hadoop ecosystem or the services all the time. They want some capabilities where like sometimes they just want to do high query, and sometimes they just want to do a Spark job. So they want to pick and choose the services which they want. And they are also looking for something like auto heal of the services. Let's say I have a cluster and some service has gone down in that cluster, and it should not be the case that they have to open a support ticket to bring that service up. It should come up automatically. So having those requirements in mind, let's see what it really takes to set it up a Hadoop cluster. So first thing what you need to do is to get the required appropriate hardware for it. So it won't, like a typical Hadoop cluster will not work for very small machines. You need to get appropriate hardware for it. Then prepare your host machines. This preparation will include, you have to RAID your OS disks for the fault tolerance. You have to partition your disks other disk for your where your HDFS data is going to be stored. You need to install your OS binaries on it, and you need to make sure that those OS binaries are work with your application. Like sometimes it happens that let's say you are working on RHEL 7.2 and your cloud, if you are taking your machines from a cloud provider, they are providing you RHEL 7.3 and your application is not compatible with that. So you have to work around that, and then you have to basically for a typical Hadoop cluster, there are three types of networks are involved. One is the private network, where your inter-cluster communication happens, and there is a secured public network which is used to reach to your cluster, and there is a management network which is used by your ops to do your upgrades and patching. And once your environment is ready, then you basically get your binaries on those machines and do a install of it. Before doing the install, you prepare your configuration. Your configuration will look like how many services will I need for this Hadoop cluster and where each service is going to sit. Like my name node will be running on host A, and my secondary name node will go on the host B, and how I'm going to maintain HA of it. So if you think you have the right configuration ready, you fire a create cluster request, and many a times you see that it fails because either your configuration was wrong or you have missed some dependency. And basically you retry again and again, and it may take maybe a few days for you to get a working Hadoop cluster ready for you for your consumption. So taking all these requirements in mind, we have actually solved this problem for our customers. We have built this service for them, which is taking care of all those problems for them, and it is hosted on Bluemix. Bluemix is a cloud platform as a service developed by IBM, and it supports several programming languages and services, as well as integrated DevOps to build, run, deploy, and manage your applications on cloud. And Bluemix is based on Cloud Foundry open technology and runs on software infrastructure. Bluemix basically provides you access to wide variety of services that can be incorporated into your application. Some of these services are like Cloud End, NoSQL, IoT, or mobile related services. And you can even use the Watson related services to leverage the natural language processing and computer visions in your apps to deeply understand the world of conversation documents or the photos. So this is our offering, which is hosted on Bluemix. It's called as BigInsights for Apache Hadoop, and provides basically a nimble model for creating you Hadoop clusters and analytics. And you can spin up your open source Hadoop cluster within a few minutes. And this service allows you basically to integrate an instance of an object store service in Bluemix also. And this integration provides you a persistent storage of your data even if the cluster is deleted, and thereby enabling an on-demand pattern of usage. So here I'm just going to do a quick demo how we can create a cluster on Bluemix and what it all takes. So this is the landing page for your, when you reach out to the Bluemix, you can see the catalog. You can order even bare metal using the Bluemix, or you can order storage, and even you can go for something like Kubernetes cluster creation on Bluemix, which is like GA'd this week only, and this will give you a fully ready Kubernetes cluster for your usage. And today I'm going to show you how we are going to make use of this Hadoop clusters on Bluemix. So this is our tile. I'll just click over it, and it will basically take me to the landing page where I can just create a service instance for this. Once the service instance is ready, I am basically on a page where can I manage my clusters, which I would have created for all the Hadoop and my Spark clusters. So I'll go to this manage cluster pages. And there I can just create all a new cluster or work with my existing clusters. And here I just need to give some details. What's my cluster name? User which I'm going to use to log into the cluster. Password for that. Confirm the password. And you can then basically choose how many data nodes are you going to need for this cluster, and what's the size of the data nodes you need for each data node. And you can also choose to have a cloud storage which can be used for your persistence. And here you can pick and choose the services which you want. I am going to pick and choose Spark and R runtime, and just click create. So this will basically take the request on my behalf, and it will take some few minutes to get this cluster ready for you. So meanwhile this cluster is preparing, I'll brief on how we are doing it, how containers are helping us to achieve this, and we'll see how this cluster goes. So how the container technology is helping us in a way is our provisioning time has come down a lot when we are using containers for creating these clusters. Let's say if we are making use of native installation, we are going from the scratch, we have to get the hardware and everything when we to deploy. It takes about 5 to 6 hours if you are a Hadoop expert to get a cluster running. If you have environment which is pre-created for you, like VMs kind of a thing, it takes about 1.5 hours to get a Hadoop cluster up and running. But if we are making use of containers and basically all our binaries are inside our images, we are able to create Hadoop clusters from range of 5 to 6 minutes. And out of that 5 to 6 minutes even, cluster creation times is about 90 seconds. And rest of the time is to start all the daemons like name node daemon or the Spark daemons. They take some time to start up. So even before boiling down to the container technology, we have done some experiments around other technologies. We have explored the usage of Chef, and we have built some recipes which we are laying down on the bare metals to create those clusters. We have also experimented around something called as XCAT, which basically takes a golden image of a running VM and replay that image on other VMs. We have also experimented using the ISO images with the Anaconda scripts to get those clusters running on the bare metals. But all these experiments were not helping us meet all the requirements which were coming from our customers. So we started thinking, we came up with from our experience and from the requirements we had, we laid down some guiding principles for deciding what technology we are going to use. The first one was like we need virtualization, and basically we are not going to create the clusters directly on the bare metals, but we need some virtualization over the bare metals, which will take care of my dependencies to be met. So we are basically looking for some imaging solution around it, and we are not going to compromise on this performance and the speed which bare metals provide to us, and we are not going to hand code everything. We are going to adopt the open source as much as possible, and we want our solution to be cloud provider agnostic also, so that basically we can work on any public cloud and don't use the vendor specific offerings from public clouds. So we started prototyping around containers, mainly from the imaging side of it. But when we tried the Docker run command for the first time, it was practically a magic for us. And like we could spin clusters so fast, even we were not expecting it to be done in such a short time. So when we started designing for running our clusters on containers, there were a lot of questions in our mind. like are we doing it right? There were questions such as how we are going to handle the scenarios of host restart, where my containers are running, how we are going to manage such scenarios, how we are going to, where is my data going to be in, whether it is going to be residing inside the containers, or are we going to mount volumes for the containers, how DevOps will react to this. So all these questions were in mind, and we started solving one by one. And we also explored at that time, about 2 years before, the orchestrators which were available at that time, Kubernetes and Swarm. But at that time, they were not meeting all our requirements. Basically, they were lacking on the requirements from the volume side of it, or the resource scheduling, which kind of resource scheduling we need. So we went ahead with our own handwritten orchestrator and solved most of those problems. And but now we are prototyping using Kubernetes for running this service, and maybe the version 3 of this offering would be running on a Kubernetes cluster. So solving all the hurdles, we built this service, and this service is currently in production. And as of now, we have run about 5,000 clusters, which has about 18,000 plus nodes. And this service is running on about 500 bare metals, and we are making use of bare metal of size like 256 gig RAM, a 48 core machine, and they have about 12 data disks of 2 TB each attached to it. And first 4 disks we are reading it together for OS, and remaining disks are for our HDFS space. And we are making use of overlay network through Weave for multi-host networking, and we are running our own private registry, and all the HDFS data goes into local storage of those machines. So this is how our typical cluster will look like. All the clusters will be networkly isolated. They can't talk to each other on the private network, but they can talk to each other on a public network. And if we look at what containers we run inside our cluster, we run a master node, which has some of the daemons running for Hadoop, like name node. And there are some containers for data nodes. And there are some auxiliary service containers like LDAP, we are using for authentication, MySQL for storing our metadata, and Ambari server, basically, which helps us orchestrate the cluster operations, and KMS for getting the keys for setting up our encryption zones. And this basically, this service breakup help us to move to something like, let's say we don't want to make use of LDAP. For the next offering, we want to make use of IPA, which does the better user management. We can easily switch over, and maybe if we don't want to make use of MySQL for our metadata, we can switch to any service. So this service breakdown helps, and we are even trying to break it down further, like wherever it is possible. And for multi-host networking, we are currently using Weave. It's one of the drivers supported for containers. Weave is doing decent job for us. We have configured Weave to give us better performance. Like if we go by the default settings, you will only be able to get 30 to 40% of the host network, which is possible. But we have configured Weave to give us better performance. Like we are now able to get about 70 to 75% of our host network if we are using Weave. We have also done some prototype using Calico as a driver, which does perform better than Weave. And we do plan to move to Calico in our next offering. And how we are able to reach out to from the public network is we do attach some portable IPs for our master nodes. And those portable IPs are listening to some ports which are SSL enabled. And then there is an edge node also provided for our users where they can do a SSH and basically run all the Hadoop shells from there and view the logs. So this is our network architecture, how it looks like. So here I just talked about how we are scheduling the containers. And So let's say we have multiple clusters, and multiple clusters can reside on this same host. But let's say a cluster A, we will run only master node and the data node on one host, and other data nodes we will schedule it to other hosts. So by this way, we are able to make use of Hadoop's replication factor into picture. Let's say even one host goes down, the cluster is not down fully, and we can still recover from it once that host is up. And we are making use of public and private network, which is a 10 gig network provided to us by software. And on the top of the private network, we are running Weave for the inter-container communication. One more thing I want to talk about here is that how we are allocating CPUs. For each container, we are giving CPU set, and we are allocating the CPUs in alternate fashion. Let's say if we have 48 CPUs on a machine, and one container needs 24 CPUs, we are not giving a straight chunk to that container. We are giving them in an alternate fashion, because in their typically hyper-threaded virtual cores, we have seen that if we give the alternate allocation of CPUs, we are getting better performance than giving a straight away one chunk together. So I'll now talk about how our cluster provisioning works. So basically, if we need to set it up, this offering on some public cloud, we first acquire hardware. We deploy our provisioning infrastructure. Provisioning infrastructure includes a bunch of apps, databases, and we have mostly containerized all of that. And then we add this prepared resource to a pool of machines, which is basically ready to take the cluster creation request for us. And then we fire basically a create cluster request comes to our API gateway. And this request will have details like how many nodes we want, what services we want. And this request goes to one of the component which is handling our resource manager. And resource manager basically decides where each node of this cluster is going to be hosted on. It decides how many CPUs each of these nodes is going to consume. It decides how much memory each of these nodes is going to take. And basically we get at the result a virtual cluster ready, which is in the form of a JSON, which then goes to our orchestrator component, which we call it as a deployer. And this deployer agent is running on each of our hosts. This deployer agent is basically a bunch of Python scripts, which takes care of the container lifecycle for us. And this deployer takes care of creating the volumes first on the host machines, and running the Docker containers with the port forwarding done, with the IP allocated, which was assigned by the resource manager, with the host name given to that container, again assigned by the resource manager, and basically then Weave allocates add that container to the network, and then basically our nodes are ready for take the cluster creation request. So we use Ambari for handling the cluster creation once our container cluster is ready. And on top of that, we fire the Ambari REST calls to do the actual Hadoop cluster creation. And then the magic of Docker imaging comes in when Ambari sees that I need to install one package. It is already installed in the image, so it skips it. So it goes, and that's how we are able to do it very faster, making use of the imaging and the container. And once the cluster is ready, we then hand it over to our user. So let's see if that cluster which we provisioned is ready or not. So I'll just do a refresh here. So this cluster is now active, and I can basically see the details of this cluster and log into this cluster using this launch console. Maybe a network is not working properly. So it's taking some time to load. Basically, when you can using this, you can reach out to your cluster. You will see all the services are running, and you can consume this cluster using our Ambari or the other endpoints which we are providing. I log into the cluster with the credentials which I provided during the cluster creation time, and you'll see all the services which I requested are running, and this is basically one data node cluster, and I have this much capacity for my HDFS, and then I can basically this cluster is ready for my taking the analytical job loads. So to summarize, we are able to create clusters in around 90-second time, and most of the other time goes in starting those clusters. We are able to create clusters reliably, repeatably. As I mentioned, we have now till now created about 5,000 clusters using this provisioning infrastructure, and we have seen about 5 or 10 failures only. That was also because of some network issues from our hardware provisioning layer. And it's a fully managed service. We take care of auto healing of these services. Like even if one of the service goes down, it comes up automatically, and it's very easy to patch these clusters, because for us the patching is only the in our development CI/CD pipeline. We create those images, and once those images are properly tested, once those images have passed our QA certificates, we just need to replace this image on our cluster provisioning infrastructure and restart the cluster. So that's all we have to do for the patching. And we are making use of optimal resources of our able to use optimal resources of our hardware. Like we are able to schedule, give the proper CPU sets which we want from our hardware, and it's been really cost effective for us also when we are using containers for running this service. I would encourage you all to try this service on Bluemix and try other services also, and basically give us feedback. I have given some links for you to try this service, and there are some YouTube tutorials also around it. If you want to explore more on the Hadoop and the Spark clusters, you can make use of those clusters tutorials to do the stuff. That's all. Thank you.